Okay, so let's begin. Before I continue, I would like to know if I'm audible enough. So can you guys hear me?
Yes, sir.
Okay, good. Now let me share my screen and we begin. Today we're looking at causal reasoning. During our class on deductive reasoning, I had mentioned that causal reasoning is a kind of inductive reasoning. But causal reasoning is a special kind of inductive reasoning that involves reasoning from cause to effect and sometimes from effect to cause. Before we discuss causal reasoning, it is very good to see the different senses of the word cause, or the different meanings, or the different ways in which something can cause something. Now, the first is proximate cause. Proximate cause means the immediate cause of something, even if that thing has more remote and foundational causes. Example, Samson decided to become an armed robber. We put him in a situation where he engaged in a shootout with the police and the police killed him. So Samson's decision to be an armed robber is the proximate cause of his death. Now we have contributory cause. When there are more than one causes, a multiplicity of causes, each of them is a contributory cause. So a contributory cause is a cause among other causes. Example, a distressed economy contributed to Samson's decision to become an armed robber and hence to end up being killed by the police. So a distressed economy is one of the contributory causes of Samson's death. We have necessary cause, or cause as necessary condition. When something is a necessary condition for another thing, without it, the other would not exist. Example, without oxygen, life is impossible. So, no oxygen, no life. Now, so oxygen is necessary for life, but there are other things that are also necessary for life. Water is necessary for life. Food is necessary for life. Sunlight is necessary for life. And so we have various necessary causes of life, but none of them is sufficient for life. None of them is adequate to produce life. That takes us to our next topic, sufficient cause, or cause as sufficient condition. Something could be a sufficient condition for an effect if the presence of that thing is adequate for the presence of the effect. One does not need to express doubt at seeing the effect when she sees the cause. Example, to be prevented from inhaling oxygen for 20 minutes is sufficient condition for death. So this is a very good example of sufficient cause. If you can manage to prevent someone from inhaling oxygen for 20 good minutes, then that's sufficient condition. It's a sufficient cause for death. Another example of sufficient cause, proving that a healthy and sane person calculatedly committed a murder is an adequate condition or cause for sentencing that person to life imprisonment, if this is the appropriate sentencing for such a crime in that jurisdiction. So if there is a country or a jurisdiction where the penalty for killing someone is life imprisonment, all that you need to do is to be able to prove that someone has killed someone, and that's adequate for life imprisonment. Even the president of that country cannot say, no, don't sentence him, because it's a law. Now we have individually necessary but unjointly sufficient conditions. We can say there are several individually necessary conditions for an effect, and that a combination of these conditions becomes sufficient for the effect. In life and in science, it is usually difficult to determine what number of causes are jointly sufficient for an effect. Now, it is not easy to know how many causes will come together to be sufficient for an effect. For instance, it's not easy to know how many causes will come together to be sufficient for life. We know water is necessary for life, oxygen is necessary for life, sunlight is necessary for life, water, food is necessary for life. But if we bring these four things together, do we have life? So we're not sure we have life if we bring them together. So that means that each of them is necessary, but coming together, they may not be sufficient. We still need to find out what will join them to produce life. So it is easier to identify necessary conditions rather than sufficient conditions. Sufficient conditions are not easy to identify. So this is the example. Oxygen, water, food, and health are independently necessary conditions for a human being to stay alive. But they and some other factors we may not know yet are sufficient for staying alive. So now we have probabilistic cause. Probabilistic cause is the opposite of necessary cause. This kind of cause is theoretically not necessary, not a must for the effect. Example, a crisis within the economy, the lack of a job, and the need to marry and settle down are probable causes of Samson's decision to become an armed robber. So none of these causes is necessary to be an armed robber. You can pass through all these conditions and yet you avoid becoming an armed robber. Many of us pass through these conditions, but we are not armed robbers. Then we have causal agent. Causal agent is also a cause. Example, Clement is the cause of the crisis. So human beings can also cause effects. Then we have causal chain and causal web. Now, causal chain is when there are so many causes, each one leading to another. So that's what makes it a causal chain. Each one is leading to another. From one to another, from one to another, from one to another. That's a causal chain. Let's see an example. Example of causal chain. Samson graduated but could not find a job. And because he could not find a job, he attempted self-employment, but did not show enough determination to succeed in his chosen craft. He went to a bar one day and met a friend who introduced him to a gang. Now, Samson decided to join the gang because he was hungry and out of cash. So, because he could not find employment and he did not succeed in self-employment, he has joined the gang. Now, he joined the gang and became an armed robber. Now, joining the gang means that he has to do what the gang does. He and his gang had a number of successful robberies, but on one of those escapades, they ran into police. So Samson's decision to become a armed robber brought him to a situation whereby he engaged in a shootout with the police. There was a shootout and Samson was hit. Samson was rushed to hospital, but he died of gunshot injuries. So you can see a chain of causes, one leading to another, one leading to another, from lack of self-employment to a bad self-employment, from a bad self-employment which was characterized by hunger and no cash, to joining a gang, from joining a gang eventually to having a confrontation with the police. And that confrontation cost Samson's death. So that's this an example of a causal chain. Now let's look at the causal web. The causal web is when the relationship between causes is more like a web than a chain. Two contributory causes could occur simultaneously. So when two causes occur at the same time, then that's a causal web. So the difference between a causal web and a causal chain is that for causal chain, the causes happen one before the other. One leads to another, one leads to another, one leads to another. So they are in a line, a chronological line. But in a causal web, they happen at once, beside one another. They happen at the same time. And they are contributing to the same effect at the same time. Let's see an example. Example of causal web. It could be that the police officer who killed Samson did so because he, the officer, aimed his gun correctly, whilst his colleagues did not. And at the same time, Samson got killed because he squeezed his trigger to kill the police person before the police killed him, but found that there were no more bullets in the firing chamber of his gun. So what led to Samson's death is that he pointed his gun at the police pointed their gun at him, both of them pulled their trigger at the same time, but the difference is that there were bullets in the gun of the police, but there were no more bullets in Samson's gun. That's why Samson died. So that's a causal web, several causes occurring at the same time and contributing to the same effect. Okay, so that's that about different senses of the word cause, or different ways in which something can cause something. Now let's look at causal reasoning. What is causal reasoning? Causal reasoning means reasoning to identify causes. Now, how do we reason to identify causes? First of all, you have the formal and informal. The informal causal reasoning patterns are the ones that every human being does. All of us as human beings have certain methods we use to identify the cause of something. Then we have the formal causal reasoning patterns. Those ones are scientific causal reasoning that was developed by scientists. That's what is used for scientific experiments. Now let's look at this slide. Causal reasoning is a type of inductive argument attempting to establish the causal relationship between phenomena or events. A causal claim indicates that something causes another. So whenever you say this caused this, you have made a causal claim. Then a causal hypothesis is an initial speculation made in relation to a causal claim. So a supposition offered as a starting point for further investigation. Now, so we want to study two things, or we're supposed to study two things. First, the various informal causal reasoning strategies for arriving at causal claims. That's the ones we do as human beings, whether we were educated to do it or not. And then we have the various experimental strategies for confirming causal hypothesis. So that's the one for scientists, and we can't do it this semester. So now to the various informal causal reasoning strategies. John Stuart Mill, in his book titled A System of Logic, proposed 5 approaches for detecting causation by observation, and we shall study only 3 of them. The relevant difference reasoning, the common thread reasoning, and the concomitant variation reasoning. So these are the 3 causal reasoning patterns we are going to look at right now. So let's begin with the relevant difference reasoning. This is a method of reasoning that identifies something that occurred differently from others as the cause of an effect. According to this method of reasoning, A is the difference among others, so A caused the effect. Now, this is an example. I've always taken tea and bread for my breakfast, but on a certain day last month, I fell sick shortly after my breakfast. I treated the illness and fell sick again last week after my breakfast. So I asked myself why I have fallen sick on these two occasions after breakfast. And it occurs to me that on these two occasions, I had taken marmalade with the breakfast. I checked the information provided on the product's container, and then I saw that the marmalade had expired long ago. I suspect that this is the reason why I've fallen sick twice. Now, since I've always taken tea and bread without health implications, it means the expired marmalade becomes the relevant difference in explaining the possible cause of the two illnesses. Now, so I've taken tea and bread all my life, and I've never had problems. Then suddenly I take tea and bread and I fall ill. I treat it and then come back and repeat tea and bread and fall ill again. And then I ask, what in this tea and bread is making me sick? What is new in the tea and bread I take? And then I discover it is a certain marmalade that I use on my bread, which I bought from a grocery store. And then I check the product's information and find that the product has expired. So that product has becomes the relevant difference explaining my problem. Then we have common thread reasoning. Now, this is a method of reasoning that identifies something that occurred in all the instances that have led to a particular effect. Identifying something that has occurred in all the instances that have led to a particular effect. According to this method of reasoning, A is the common thread among all the events, so A is the cause. So this just involves identify something that runs through all cases of a certain problem. Example, when I bought the marmalade some months ago, I had gone shopping in the company of my neighbors, and we had all bought the same stock of marmalade, which expired at the same time. Now, assuming my neighbors are equally sick, they all trace the cause of their illnesses to the expired marmalades. It means we have all identified the expired marmalade as the common thread in all the cases of this particular illness in the neighborhood. So you can see that common thread involves identifying something that is similar to several cases. That's why we call it a common thread. It's like a thread running through several cases. Now, we often use relevant difference and common thread together. If there's an epidemic in a population, the first thing you do is to test one person to find out what is wrong with the person, to find out what is the relevant difference in that person that is making him or her sick. The person has always been healthy, and and now the person is sick. What happened? What happened differently to the person in his or her environment to make him or her sick? And then you might find out that it's a virus that the person contracted maybe 1 month ago. If you discover that, then it means the virus is the relevant difference in explaining the person's illness. Once you have identified the virus in the person, then the next thing you'd ask, the next question you'll be asking is whether it is the same virus that is causing the same problems or symptoms in others in the population. So you go ahead to find out whether others have the same problem. And then if you find out that others have the same problem, then it means that the virus is also the common thread running through all the cases in the population. So that means you have identified an epidemic. You had, first of all, you identified a relevant difference in someone, and then you identified that relevant difference as also a common thread in others who have the same problems with that person. Now, third, this third method is not the same as the last two. It is totally different. Now, concomitant variation is a method of identifying the degree of occurrence of something rather than its simple presence or absence. Now, so you use this one to identify something's the degree or intensity of something, not whether such that thing is present or absent. It is used when we cannot eliminate a particular cause from the environment. Example, carbon dioxide. Now, carbon dioxide is also always in the air. There's no atmosphere that has no carbon dioxide. Now, but if carbon dioxide is causing a problem in an environment, then probably it is because it is too much in the atmosphere. So when you are trying to determine the relationship between carbon dioxide and a particular problem, you are measuring for the degree of carbon dioxide, not whether carbon dioxide is present or absent. Now, so it is useless to use relevant difference to identify carbon dioxide as a cause of ill health. You rather use a method that measures its degree or intensity. Example, it was revealed through research that high blood pressure is exacerbated in regions whose soils have low levels of selenium. Now, this is a metal that exists in tiny quantities in every soil. And because of this, we cannot measure for its absence or presence. We can only account for the effects of varying degrees of it, and hence the discovery that it seems correlative with the ability of our bodies to keep our blood pressure normal. So selenium is a metal that exists in every soil, but it was discovered that if the quantity of selenium in a piece of soil is too small, then those living around that place are going to have high blood pressure. So a certain quantity of selenium is needed in the soil for people's blood pressure to be normal. So it means that selenium has an effect on our blood pressure. Second example, it was discovered that high levels of sulfur dioxide. Now, sorry, let me go back to the first example. Now, so it means that if you want to find out whether the high blood pressure in a place has anything to do with the selenium in that place, you wouldn't be measuring for the presence or absence of selenium. You'll be measuring to see the degree of selenium in the soil so that you know which degree is causing high blood pressure and then which one would bring down the blood pressure to a normal level. Okay, so that means you'll be using concomitant variation as your method of identifying the cause of high blood pressure. Second example, it was discovered that high levels of sulfur dioxide pollution in the air was responsible for high rates of deaths in London between November and December 1952. Now, there's no way to eliminate sulfur dioxide from the air, but the experiment discovered the causal connection by comparing the increase and decrease of the effect, which is the number of deaths per day, to the daily variation in degrees of sulfur dioxide fumes in the air. So every day you count the number of people who died and also measure the degree of sulfur dioxide in the air. And then you see from one day to another, you see the level, the degree of sulfur dioxide that causes deaths. You also see the level that doesn't cause deaths. So that's concomitant variation. So that's that about the three causal, informal causal reasoning strategies that we use as normal, as ordinary people. You know. Now let's look at how not to identify causes. How do we avoid identifying the wrong causes? There are certain wrong ways of identifying causes. We call them causal fallacies or fallacies of causal reasoning or bad causal reasoning. These fallacies are committed when the link between an alleged cause and effect depends on a causal link that does not exist. Let's look at the first causal fallacy. We call it post hoc ego propter hoc. or the fallacy of inferring causality from chronology. What is chronology? Chronology means the passage of time, you know. So anything referring to chronology is referring to the movement of time. Example, for the first time today, I took beans for breakfast and I performed wonderfully in my mathematics text. Therefore, a breakfast of beans is very crucial to mathematical proficiency. So for the first time in your life, you take beans for breakfast and then you go in for a mathematics text and then you get 100%, probably also for the first time. And then you become tempted to think that the beans could have something to do with your performance, particularly because you ate it for the first time and look at the result, which is also the first ever result of that kind you are seeing. So you begin to think that the beans may have had something to do with your performance at the mathematics test. But the fact that something happened before another thing doesn't mean that it may have caused it. You need more proof to show that something that happened before another caused it. So you need more proof to show that the beans you took for your breakfast had anything to do with your performance in the mathematics test. Then we have non-causal pro-causal, the fallacy of exchanging cause for effect. Exchanging cause for effect. You take an effect and you say it is the cause. You see cause and then you say it is the effect. Example, Michael is a poor student because he performs poorly in examinations. But that's wrong. To correct it, we'll say, Michael performs poorly in examinations because he's a poor student. So being a poor student comes before performing poorly in examinations. Or two people are fighting. Let's say Kofi slaps Amma, and then Amma slaps Kofi back, and a fight begins. And they are in court. Kofi says that it is Amma. The judge asks the question, who slapped first? And then Kofi said it is Amma. That is exchanging cause for effect. Because the cause of the fight is that Kofi slapped Amma. So when Kofi says in court that Amma slapped first, then Kofi is exchanging cause for effect. Oversimplified cause. This occurs when there are many causes and the argument identifies only one of them as a cause. Example, the Cameroonian team won the trophy because their coach is paid a higher salary. Now, so a team can only win a trophy if the players play well. So a high salary alone cannot bring trophy unless the high salary leads to higher performance, unless a higher salary leads a coach to take a decision to coach his team well enough to win. And not only that, his team accepts his proposal and they play well enough to win. Those are the things that would secure a trophy. So not just a higher, you see that a higher salary is not what can give you the trophy. Then we have false common thread. Now, so we saw how to identify common threads. There are some common threads that are not true. We call them false common thread. When we infer a common thread as a cause when it is not. Okay, example. All the academically bright guys in my class have cars, so I will get a car as part of my desire to be academically bright. Now, the issue is whether having a car will make you academically bright. If having a car cannot make you academically bright, then it is a false common thread to say that all those who are academically bright have cars. So it is a car that made them bright. Confusing correlation with causation. What is correlation? Correlation is when two things always happen at the same time. Like when there's fire, you see smoke and things like that. Causation is that one thing causes another. Now, correlation doesn't always mean causation. The fact that two things always occur together doesn't mean that one of them is causing the other. Okay, so just because two things occur together does not mean that there's a direct causal relationship between them. Example, each time a car moves, we see smoke coming from the exhaust tube. Therefore, the smoke causes the car to move. Now, this is wrong. If a child makes this kind of argument, then you can correct him or her by saying, the smoke is not what causes the car to move. Both the movement and the smoke are caused by the engine combustion. Slippery slope. When we commit slippery slope when we suggest that there's a relatively insignificant event. A relatively insignificant event will cause a more significant event, which in turn will cause an even more significant event, and the order of significance continues to increase without adequate justification as to why each significant event will lead to a more significant event. So a progressively dubious chain of premises, usually consequences, is often employed to support a conclusion or claim. So when you claim that if something happens, it will lead to something more serious, which will lead to something more serious, which will lead to something more serious, and so on, and the order of seriousness continues to rise until probably something terrible happens. Example. Okay, before we see examples, another explanation. This is the fallacy of arguing that if A is allowed, it will trigger a set of events that will eventually lead to Z, and then it is only a matter of time to go from A to Z, to slip down a slippery slope from A to Z. Now, this should not be a fallacy if the causal movement from A to Z is justified. But it is a fallacy if the causal movement is not justified or justifiable, which means that it is fatalism, an extreme version of determinism. First example, if Donald Trump becomes the president, America will fight many wars. This was what the Democrats were saying in the USA 2016 presidential election campaign. So eventually that didn't happen. So it is a fallacy of slippery slope. Now they were saying this because it was clear to everyone that Donald Trump is an aggressive person, But being an aggressive person doesn't necessarily mean that you start a war, What they forgot is that Donald Trump is a rich man who has investments all over the world. So if he starts a war, his own investments are going to be destroyed, All right. Second example. It is wrong to believe in God because then you will eventually believe in not just God, but all kinds of spirits. And then you come to believe that spirits have all kinds of power. And then you come to believe that inanimate objects have spirits. And then you come to believe that everything at all has spirits and power to do something or the other, thereby ultimately destroying your ability to evaluate cause and effect in natural terms. So this argument is saying that if you believe in God, eventually you believe that everything around you has power, which is false, because most people who have believed in God didn't end up like that. The third example, I cannot allow my child to go outdoors and play in a compound. This is because if I do, she will jump fence and go into the streets. If she goes into the streets, she will run away with any stranger. Any stranger. If she runs away with any stranger, then I'll never see her again. If I never see her again, I'll be miserable for the rest of my life. If I'm miserable for the rest of my life, I'll commit suicide. So for the purpose of the avoidance of suicide, I will not allow my child to play outdoors in my compound. So this argument is essentially saying that if I allow my child to play in my compound, which is actually gated and fenced. Her playing in my compound will lead to my suicide. That's the argument. So if the argument is not justified, then it is a slippery slope argument. This is the end of the class. We shall study informal fallacies next class. So I encourage you to watch your lecture videos regularly, read your textbooks regularly, do the exercises in your textbooks, all of them. Check your Sakai platforms regularly for updates, announcements, and assessments. Do the same to your WhatsApp groups. Good luck. At this point, I'll take questions. If anyone has questions, you can ask. If there are no questions, then I would, or rather after questions, I would close the class and then upload the video to your Sakai so that all those who have not attended this class will start watching the videos. All right, so if anyone has questions, you can raise your hand and then I'll ask you to speak, after which we'll close the class and then you get the video on your Sakai. Okay, so there are no questions. It's a pretty straightforward class. Now, I hope you did well in your assessments. Remember to do your assignments, assessments, and all those things in the middle of the night between 12 a.m. and 2 a.m. so that the network will not disappoint you. All right, and you should be receiving your next assignment by Monday, and then your IA should be coming a week after that. All right, good luck. Have a nice weekend. Work hard so that you can all be great. Bye-bye.
Thank you, sir.
Bye.